What exactly did China discover on the far side of the moon? And why are countries around the world so eager to return? For decades after the brilliant success of the Apollo program, humanity's gaze gradually shifted to other planets in the vast cosmos. In 1976, the Soviet Union brought back the last precious samples from the moon, marking the end of an era. However, almost in an instant, the global race for lunar exploration has ignited once more. New space exploration rockets shoot towards the sky like an arrow from a bow, as nations vigorously advance their own lunar exploration plans. In this previously untouched domain, China has been moving forward steadily and with quiet determination. For a time, rumors of strange discoveries on the far side of the moon spread like wildfire. People can't help but wonder, what secrets lie hidden beneath the thick lunar dust? And why are all the world's nations in such a hurry to return to the moon? Let's first go back in time to understand some necessary background information. China's lunar exploration journey began in the early 21st century. The China National Space Administration, CNSA, meticulously formulated a highly ambitious phased plan. Subsequently, it launched a series of probes and landers named after the ancient Chinese moon goddess, Chang'e, with the aim of systematically and thoroughly studying our closest celestial neighbor, the moon. In 2007, Chang'e 1 was successfully launched. As China's first lunar orbiter, it used advanced technology to create high-precision 3D maps of the lunar surface and conducted a detailed analysis of the lunar soil's composition. It's worth noting that instruments aboard Chang'e 1 detected signs of helium-3 in the lunar soil for the first time, a discovery that undoubtedly hints at China's high level of interest in the moon's potential resources. In 2010, Chang'e 2 was launched with a new mission. Equipped with a higher resolution camera, it conducted a comprehensive survey of potential landing sites for subsequent lunar missions. During its mission, Chang'e 2 flew at an ultra-low altitude of just 9 miles above the lunar surface, capturing a large number of clear images that provided crucial data for assessing the safety of landing zones. Just 3 years later, China's space program achieved a major breakthrough. Chang'e 3 successfully performed China's first soft landing on the moon. The spacecraft precisely landed in the Mare Imbrium, Sea of Rains, region on the moon's near side and successfully deployed the Yutu rover. This was the world's first lunar landing since 1976, breaking decades of silence. The Yutu rover also carried an ultraviolet telescope, the world's first moon-based observatory, opening a new perspective for humanity's exploration of the universe. The launch of Chang'e 4 in 2018 was a milestone in human space history. Originally a backup for Chang'e 3, it was repurposed for the arduous task of exploring the far side of the moon. No spacecraft from any country had ever successfully landed on the far side of the moon before. The technical difficulty was immense. Due to the moon itself blocking signals, a probe on the far side cannot communicate directly with Earth, which became a huge obstacle on the path of exploration. To solve this problem, China creatively launched the chang'e relay satellite and precisely positioned it at the Earth-Moon Lagrange point 2. This satellite acts like an invisible bridge, maintaining a continuous line of sight with both Earth and the far side of the moon, providing a solid foundation for subsequent communications. On January 3, 2019, Chang'e 4 successfully landed in the von Karman crater on the far side of the moon, achieving the first ever soft landing on the lunar far side. The Yutu rover then slowly rolled out, leaving the tracks of human exploration on the lunar surface. The landscape of the far side it captured was something humanity had never witnessed up close before, providing precious, first-hand data for scientists studying the moon. The geology of the far side is significantly different from the near side. It lacks the large, dark lunar Maria common on the near side. Instead, it has a thicker, more heavily cratered crust. By exploring the far side, Chang'e 4 hopes to solve a long-standing scientific puzzle: why the two sides of the moon are so different. During its exploration, chang'e made many remarkable discoveries. Among them, the resource helium-3 has received much attention. Helium-3 is extremely rare on Earth but exists in large quantities in the lunar soil, deposited over long periods by the solar wind. In theory, helium-3 is an ideal fuel for nuclear fusion, capable of providing humanity with clean and efficient energy. If large-scale mining could be realized, it could satisfy Earth's energy needs for thousands of years. In 2020, scientists discovered a brand new mineral in the lunar samples brought back by chang'e and named it chang'e-Y. Surprisingly, this mineral contains helium-3. In addition to resource-related discoveries, U-2 encountered some peculiar phenomena during its exploration of the far side. In 2019, it found a shimmering, uniquely textured reddish patch in a small crater, which was distinctly different from the surrounding lunar soil. This discovery quickly sparked widespread global attention and speculation. When the photos were finally released, scientists determined through spectral analysis that the substance was impact melt breccia, a glassy material formed when lunar rock melts under the high temperatures of a meteorite impact, rich in minerals like olivine and pyroxene. Chang'e also undertook a groundbreaking mission, a miniature biosphere experiment. Researchers sent a sealed, bucket-like container to the moon, loaded with soil, seeds, and insect eggs. In January 2019, exciting news came. Cotton seeds inside the container successfully sprouted in the lunar gravity environment, with a tender green shoot breaking through the soil. This small cotton seedling became the first plant in human history to grow on another celestial body, holding extraordinary symbolic meaning. Although the seedling unfortunately died after 2 weeks due to the temperature dropping to -62 degrees Fahrenheit and a lack of sunlight after the lunar night began. The experiment fully demonstrated the possibility of Earth life growing in extreme alien environments, providing valuable experimental data for establishing a future ecosystem on the moon for long-term stays. The series of major achievements by China in lunar exploration quickly caused a strong reaction in the global scientific community. Western researchers praised China's technical strength and scientific results. Although U.S. law restricts NASA from official cooperation with China, the two sides have engaged in some level of data exchange regarding the moon. NASA also congratulated China. However, these achievements have also inevitably led to various speculations and controversies. Due to the mystery of the far side and the relative secrecy of some of China's mission information, numerous conspiracy theories about alien life and secret bases have appeared on the internet. For example, some special objects discovered by U-2, like the mystery hut that was initially a hot topic, sparked endless public imagination before detailed information was released. But as exploration continued, these so-called mysterious objects were eventually confirmed to be just oddly shaped rocks. From a strategic perspective, the fact that China's lunar program is directly supervised by the military has raised concerns among some international observers. Some speculate that a Chinese base on the far side of the moon could have military purposes, such as hiding military activities or establishing surveillance or missile detection points. But in fact, the instruments carried by Chang'e are all for scientific research purposes, and its payload information has been publicly disclosed. It even includes instruments provided by European countries, such as a Swedish neutron detector and a German radiation experiment, which fully demonstrates the openness and scientific nature of China's lunar program. China's rapid development in lunar exploration has created a situation of both competition and mutual promotion with the plans of countries like the United States. Through the Artemis program, the U.S. is collaborating with private companies like SpaceX and Blue Origin, as well as several allied nations, to return American astronauts to the moon and establish a permanent base at the lunar South Pole. The Artemis 3 crewed landing mission, originally scheduled for 2024, has been postponed to after 2025, with an expected actual landing around 2027. But it still demonstrates America's strong determination in space exploration. China, on the other hand, has a clear lunar exploration plan, aiming for a crewed landing before 2030 and actively promoting the construction of the International Lunar Research Station, ILRS. In 2020, Chang'e 5 successfully brought back samples from the moon's near side, including lunar rocks about 2 billion years old, which are the youngest lunar rock samples found to date. In 2024, Chang'e 6 successfully completed its mission to collect samples from the far side of the moon and return to Earth, bringing back about 4.5 pounds of lunar rock. The subsequent Chang'e 7 and Chang'e 8 missions are planned for launch in the late 2020s, targeting the lunar South Pole to search for water ice resources, study the polar environment, and test in situ resource utilization technologies to lay the foundation for a future lunar base. Although there is a competitive relationship between China and the US in space exploration, there is also a possibility for cooperation. While policy restrictions prevent direct cooperation between NASA and the CNSA, the two sides have achieved a degree of indirect collaboration through intermediaries like Europe. However, as countries' interest in lunar resources grows, a key issue needs to be resolved. How should the ownership of lunar resources be defined? The Outer Space Treaty of 1967 clearly prohibits nations from making sovereign claims on the moon. But in the future, when countries begin to mine lunar resources, it will be necessary to establish new international rules and agreements. Today, the moon has become the central stage for the 21st century space race. This race is fundamentally different from the space race of the 1960s. Back then, the focus was on who could be the first to land on the moon and leave a human footprint. Now, the core of the competition is about establishing a sustainable human presence on the moon to lay a solid foundation for future space exploration and resource development. Will the results of future lunar exploration promote cooperation among nations for mutual benefit? Or will they intensify competition, leading to the division and struggle for lunar resources? For now, the mysterious veil of the far side of the moon is gradually being lifted. As exploration by various countries continues and private enterprises become more involved, the moon may become a new starting point for humanity's exploration of the universe.